Along the Harengracht Canal in Amsterdam stands a narrow house built in 1662 that leans roughly 8 inches toward the water and looks as though it could collapse at any moment. The facade is just over 16 feet wide. It rises more than 59 feet. Its exposed brick walls weigh several dozen tons, and yet the structure remains standing, supported by 40 timber piles driven into the marshy soil of the Netherlands during the 17th century, on ground that any modern engineer would examine with suspicion before constructing even a simple shed. The house is not an exception. Anyone walking through Amsterdam's historic center will encounter hundreds of facades leaning forward, sideways, and sometimes in both directions at once. The city resembles a theater of suspended collapse, filled with buildings frozen midway through an improbable fall. And here lies the paradox. What appears to be obvious evidence that a building is collapsing is, in many cases, precisely why it remains standing. There is a natural temptation to look at these crooked facades and assume they are mistakes. Homes that aged badly, foundations that failed, an urban center composed of slow-motion ruins waiting for someone to deliver the final push. The assumption makes sense. No other urban ensemble of comparable importance presents visitors with such a dense concentration of visibly leaning buildings. In Rome, the ancient buildings look weathered, but they generally remain vertical. In Paris, Haussmann's city blocks maintain an almost military alignment. In London, even Georgian buildings remain plumb. Amsterdam does not. Travel guides present Amsterdam as a city that apparently refused to correct its own angles. And this is where the contradiction must be stated plainly. A city built on marshland, supported by timber logs submerged for centuries, over soil that should yield under the slightest weight, has preserved some of the oldest and most valuable residential buildings in continental Europe. It should not work. It does. Before unraveling the paradox, we need to make it even stranger. To begin with, the ground beneath Amsterdam is what geologists call saturated soft cohesive soil. For the first 33 to 39 feet beneath the historic center, the ground consists of peat and clay, with such a high water content that an excavated trench can spontaneously turn into a small canal within minutes. There is no bedrock, no natural pavement, no meaningful bearing capacity. It is the kind of ground where a person weighing 154 pounds can leave an impression simply by standing still for too long. Placing a 4-story house made from solid brick on top of this soil, with a tile roof, timber floors, furniture, residence, and an attic often packed with merchandise, is like balancing a stack of books on a cup of coffee that is still hot. Add the fact that the city lies almost entirely below sea level, protected by a complex system of dikes, canals, and floodgates, and the problem becomes almost absurd. A city that should not exist was built on soil that should not support it, with houses deliberately designed to lean, and the entire ensemble became a World Heritage Site. How does any of it remain standing? The first layer of the answer lies beneath the ground, where no one can see it. When Dutch builders of the 16th and 17th centuries decided to erect buildings on soft ground, they did not attempt to compact the soil or drain the subsurface. They did something more ingenious. They drove clusters of long timber piles through the peat and clay, most of them imported from Scandinavia and made from pine, spruce, or alder. These piles passed through the soft layers and stopped only after reaching a firm stratum of compacted sand, between 33 and 39 feet below the surface, and, in some places, nearly 60 feet down. Each pile measured roughly 8 inches in diameter at the head and tapered to around 5 inches at the tip to make driving it into the ground easier. Every house along the principal canals was supported by a varying number of piles, between 40 and 300, depending on its size, arranged in dense rows beneath the main walls. The engineering is sophisticated even by modern standards. The city's royal palace on Dam Square, one of Amsterdam's most imposing buildings, was erected during the 17th century on a submerged forest of 13,659 Scandinavian timber piles. A figure tour guides proudly repeat, as though it were a mythical number. It is not mythical. It has been counted, verified, and documented. What supports the palace today is essentially the same foundation that supported it in 1665. But this is where we encounter the first technical subtlety most visitors never learn. Contrary to what intuition suggests, timber does not decay underwater. It decays only when exposed to oxygen. As long as a pine pile remains completely submerged and surrounded by water-saturated peat, it can survive for centuries, virtually intact. The water forms a natural preservative layer, almost like a sealed container. That is how logs driven into the soil before Rembrandt painted the Night Watch in 1642 remain structurally functional beneath the city's buildings today. The problem begins when the groundwater level drops for any reason. Perhaps a pumping system is operating too aggressively. Perhaps nearby construction temporarily drained the subsurface. Or perhaps local water authorities, the institutions known as Waterschappen, adjusted canal levels for technical reasons. When that happens, the tops of the piles, the sections closest to the surface, become exposed to air. Fungi and bacteria go to work. Within a few decades, the upper section of what was once a solid log can turn into damp powder. The house loses support at specific points and begins leaning toward the compromised pile. The building itself is not falling. The ground beneath it is rearranging itself, one pile at a time, silently, across generations. The second layer of the answer lies in the shape of the buildings. And this is where the contradiction becomes even more fascinating, because much of the leaning that tourists photograph as a sign of decay was actually part of the design. For nearly 3 centuries, from the late 16th century to the early 19th century, Amsterdam required house facades to be constructed with a slight forward lean toward the street or canal. In Dutch, the practice was called opvlucht bouwen, which can be translated approximately as building on a slope or building in flight. The city's building code even specified how far the facade should project. Corner houses had to lean toward both exposed sides at once. The rule emerged from very specific practical needs. During the Dutch Golden Age, Amsterdam was Europe's leading commercial and port city. Its population grew from approximately 30,000 residents in 1585 to 240,000 in 1680. Goods arrived from every corner of the known world: cotton from the southern United States, spices from the East Indies, cocoa from South America, and coffee from Asian colonies. Amsterdam's merchants did not separate their homes from their warehouses. They stored merchandise in the attics of their own residences. And the city's 3 main canals, the Herengracht, Keizersgracht, and Prinsengracht, excavated between 1663 and 1682, formed an immense avenue of brick facades, each functioning simultaneously as a home, office, and warehouse. The problem was that the stairs inside these homes had to be narrow and steep because the lots themselves were so slender. Some original stair treads in the historic center are only about 6 inches deep and rise at angles that modern industrial safety standards would consider dangerous. Carrying a sack of coffee or a barrel of indigo up a staircase like that was simply impractical. The Dutch solution was elegant. At the top of every facade, builders installed a projecting solid timber beam fitted with an iron hook, known as a Heisbalk. It was a small domestic crane. A rope ran through a pulley and down to the street, allowing merchants to hoist cargo through the wide attic window. The crucial detail was that if the facade were perfectly vertical, the suspended load would swing against the wall whenever it was raised, striking the bricks, scraping the plaster, and shattering glass windows that cost small fortunes at the time. By leaning the facade forward a few degrees, builders ensured that the suspended package would rise clear of the building without touching anything. The inclination, therefore, was not a symptom. It was a machine, an immobile machine embedded within the city's architecture, designed to move merchandise without using stairs. Even today, 3 centuries later, the system remains in use. Residents moving into or out of historic Amsterdam apartments frequently hire specialized companies to hoist sofas, refrigerators, and beds through upper-story windows, following exactly the same vertical route Golden Age merchants once used to lift barrels of tobacco. If you walk along the canals today and look closely, you will see these hooks still projecting from the upper sections of virtually every historic facade. Some are discreet, nothing more than a timber beam and a hook. Others are sculptural, supported by ornamental brackets shaped like human heads, animals, or Baroque scrolls. Without exception, all of them remain functional. The maritime trade of the Golden Age disappeared. The hooks remained. The third layer of the answer is the invisible physics constantly at work behind these leaning facades. And here we find a figure that may explain better than any diagram why Amsterdam's houses do not fall. When a building leans forward, its center of mass shifts in the same direction. If the inclination is gentle, between roughly 3/4 of an inch and 2 inches for every 3 feet of height, the center of mass remains within the building's footprint, preserving its stability. When the lean exceeds approximately 8 inches for every 3 feet of height, the critical ratio of 1:20, the building enters a danger zone and requires immediate structural intervention. That often means replacing the original, timber piles with concrete or steel piles driven alongside them. Municipal authorities regularly monitor these angles. Every historic house in the city center has, somewhere in an archive, a record showing how far it has moved since the previous survey. Modern engineering has essentially assumed the role of a geriatric physician for historic buildings, monitoring the minute aging of each facade and deciding when intervention is necessary and when the structure can simply be allowed to continue as it is. There is an additional visual effect almost no one notices. When a facade is built perfectly vertical, with straight walls and absolute plumb, someone looking up from street level receives the optical impression that the top leans backward, away from the observer. It is the same effect that makes a tall building appear to taper when viewed from close range. Even without describing this distortion through the language of modern optics, Dutch builders intuitively compensated for the phenomenon. A facade leaning slightly forward canceled the illusion and restored a sense of vertical alignment for the observer standing in the street. 5 degrees of deliberate design could accomplish more than 0 degrees of geometric perfection. The fourth layer, the human and cultural decision that consolidated all of this, crystallized during a specific episode in the city's history. In 1452, a devastating fire swept through Amsterdam. Most medieval homes were constructed from timber, and the flames spread from facade to facade with brutal ease. After the disaster, the city council gradually required new buildings to use brick. Brick provided greater safety, but it did not change the inherited building customs. Builders continued designing tall, narrow, projecting houses, now executed in masonry instead of exposed timber framing. What had been jettying during the Middle Ages, a technique in which upper stories projected over the lower levels to protect the facade from rain and create additional interior space, evolved into a continuous lean across the entire facade. A carpentry tradition became a rule of masonry construction, and in 1663, when the city launched its fourth expansion, the ambitious urban plan that excavated the ring of three main canals, in just over 2 decades, the lots sold to wealthy merchants were measured according to a punishing criterion. Property taxes were calculated according to the width of the lot frontage, the section of the house facing the canal. The narrower the facade, the lower the tax. Merchants responded with a ruthlessly geometric solution. They built homes 16 feet wide, sometimes even narrower, extending 100 to 130 feet toward the rear of the lot and rising 4 or 5 stories. Minimum facade, maximum interior volume. And because that narrow facade concentrated all the owner's vanity, the ornaments at the top, the stepped, neck, bell, and clock gables, acquired disproportionate importance. Leaning the facade forward also made these ornaments more visible to anyone looking up from the street. Vanity, taxation, and engineering were all resolved through the same architectural gesture. Even with all these factors explaining nearly everything, part of the paradox remains unresolved, and it is this uncertainty that continues to intrigue engineers working with Amsterdam's historic foundations. No one knows exactly how much longer each pile beneath the historic center will survive. The piles were driven in successive phases over several centuries, made from timber of varying quality, harvested from Scandinavian forests that no longer exist in their original form, and buried under saturated conditions dependent on the city's delicate hydraulic balance. Recent studies conducted by researchers working with colleagues in Venice, a city facing an almost identical problem, are attempting to map the condition of these piles using micro-drilling and timber core analysis. The difficulties are enormous. Accessing the piles beneath a house requires removing the floor, a procedure involving historic preservation approval and considerable disruption for residents. Climate change further complicates the situation. Increasingly, dry summers lower the groundwater table. In recent years, municipal authorities have warned that hundreds of buildings in the city center may require structural reinforcement over the coming decades, at an estimated cost of billions of euros. 4 centuries after learning how to build on marshland, the city is still learning how to keep those buildings standing. One particular house serves almost as an emblem of the problem. At number 116 on Roken, a former waterway later transformed into an avenue, stands a building constructed in 1733 and remodeled in 1881. It leans forward so dramatically that almost every passerby looks twice. Roken was originally an arm of the Amstel River and was not filled in until the 1930s. The Yeri house has passed through the hands of a Persian carpet merchant, an art dealer, and a Nazi cultural looting organization during the Second World War. It remains there today, leaning farther than most of its neighbors and still breathing beneath its own weight. It is a concentrated example of what the entire city does. It holds. It leans. It holds again. It adjusts. It holds once more. There is no single moment when anyone can say that the building has finished settling. It is always in the middle of some minute movement, millimeter by millimeter, decade by decade, guided by the behavior of the piles beneath it and the neighboring buildings beside it, with which it shares mutually supporting party walls. Now return to that house on the Herengracht Canal, the one from 1662, leaning 8 inches toward the water. A tourist passing by can read everything its facade has to say, if they know where to look. The bricks came after the fire of 1452. The narrow width came from the tax on lot frontage. The height came from the population explosion of the Golden Age. The forward lean came from the need to hoist merchandise without striking the wall, the desire to display the ornamented gable, and the intuitive correction of an ancient optical illusion. The 40 Scandinavian pine piles remain beneath it, submerged and silently preserved by water that the city spends enormous sums to maintain at precisely the correct level. What appears to be falling is what keeps it standing. What appears to be a mistake was deliberately engineered. What appears to be neglect is the most sophisticated use of geometry available at the time. The entire city works this way. Amsterdam does not defy gravity. Amsterdam negotiates with it every day, as it has for nearly 4 centuries, in a conversation that never ends. Thank you for staying until the end. Leave a like and subscribe to the channel. I will be waiting for you in the next video.